Welcome to Mr. A's Geometry Podcast. Thanks for joining. What I want to take a look at with you today is just a very simple application of a subtraction proof. Right? Subtraction postulate allows us to take a large piece and subtract it down to get something smaller. So in this proof, we're told that AC is congruent to BD. So AC is this long section here, and that's congruent to BD, this long section here. What they're asking us to prove is that AB is congruent to CD. In other words, these little end pieces here. The way that you know this is a subtraction problem is you're starting with larger pieces, in this case AC and BD, and you're being asked to prove that some smaller piece is congruent. In this case, AB and CD. So how do you do that? Well, what we want to do is start with AC, and we're going to take out BC. We're going to start with BD and take out the same, BC. So we have this statement about large parts congruent to large parts, AC and BD. The first thing we need to do to set ourselves up for subtraction is break those large parts down into smaller pieces. What kind of a step is that? When you take something large and break it down? That's partition. So here in step 2, we're going to say AC is congruent to, and we're going to break it down. How can we write AC as the sum of its parts? Well, AB plus BC. That's exactly what we're going to say. AB plus BC. We're going to do the same thing with BD. We need to break BD down into the sum of its parts. Well, that would be BC plus CD. And again, our reason for this is a partition step. Okay. So why do we want to break those down? What's the purpose? Well, the purpose is that we need to set ourselves up to take BC away from both sides so that we're left with what we want, A, B, and CD. We accomplish this by doing a quick substitution. We're going to take this step in 2, and we're going to rewrite it. This step in 1. We're going to take this first line and rewrite it here in step 3. But this time, instead of writing AC, I'm going to substitute AB plus BC. I can do that because of this partition line. I'm also going to substitute BD with BC plus CD. So when we do that, what we get is this. Instead of AC, we have AB plus BC congruent to. Instead of BD, we have BC plus CD. And that's substitution. By the way, what steps am I doing substitution with? Well, I'm taking this original step and substituting pieces from 2. So this is substitution on 1 and 2. Okay. So we're set up pretty much for the subtraction now. We have AB plus BC congruent to BC plus CD. We want AB congruent to CD, right? That's what they're asking us to prove. So what do we have to take away? Well, we have to take away BC over here and BC over here. Now remember, we can do that just as long as we're taking the same thing away from both sides. So before you subtract, make sure you tell me that in step 4, BC is congruent to BC. This is a reflexive step. And this sets us up for subtraction. Now, it's pretty clear that if we subtract these 2 lines, right, AB plus BC minus BC, well, the BC's cancel out. You get left with AB. How about on the right-hand side? BC plus CD minus BC. Well, the BC's cancel out again, and you're left with CD. Our reason is subtraction. Subtracting with steps 3 and 4. And that's all there is to it. But a proof box to show that you're done. So subtraction isn't very complicated. It just takes a little bit of practice because you need to set yourself up. Notice that the very last thing we did was subtraction. I know you want to subtract right in the beginning, but you have to take some time to get ready to subtract, and that's the key. If you give yourself a chance to set it up properly with a partition and a substitution step, then the subtraction comes out easily, and it's very clear that you're left with AB congruent to CD. I hope that helps. If you have any questions or things that you'd like to see me do, please write in and let me know, or just stop by in class and tell me. Thanks for watching. Have a great day.